So after those first awesome talks, I feel like I need to talk about hearing Sudoku through the web API or something, because those are awesome. But we will not be listening to anything. We're going to be visualizing. My dad loves Sudoku, and for a few years, he would solve a Sudoku puzzle basically every night before he went to bed. And when I heard about the theme of Bang Bang Con, it's about the joy and surprise and the fun in computing, I thought, well, I think this is a good topic because it brought me joy, but it also brought my dad joy. So I thought, well, for Christmas, what if I gave him a Sudoku book? And it was like a year of Sudoku. I think that'd be pretty cool. So I started looking around. I couldn't find any. And while I was looking around, I kind of got a little more into the world of Sudoku and realizing how deep and crazy it is. There's all sorts of different, as with any hobby, the deeper you go, the more language you learn and the more things you learn about it. But as I looked through it, I couldn't find exactly what I wanted. But I knew there were all these strategies, and I knew my dad didn't know them. So I thought, well, what if I can make a Sudoku book that got harder as the year went on? So it progressively got a little harder. It progressively started adding new things you had to understand, new strategies you had to implement to solve these. And I thought, well, I'm a developer. I can figure this out. So I went for it. So for me, half the fun of programming is just figuring stuff out, right? I'm going to show you some really ugly code, all right? But it does what it does what it's supposed to do, and it brought joy to me and my dad. So for those of you who don't know, this is a Sudoku puzzle. This is actually a page from the book that we're about to create here. And Sudoku puzzles, 9 by 9 grid. And in that 9 by 9, there's little groups of 3. There's 9 big boxes as well. And so in each row and column and big box, the digits 1 through 9 are supposed to be in there only one time. That's all the time I have to describe Sudoku. So if you don't know how to do Sudoku, sorry. But as you get deeper into it, there's all these solving strategies. There's full houses, naked singles, which, locked triples, hidden quads, X-wings, swordfishes, initio forcing chains. I don't even know if I'm pronouncing that right, but how cool is that, right? I just solved Sudoku with a initio forcing chain. I still don't know what that means. So as I got into this, I was like, well, it'd be cool if my dad could learn these things as he went through this year of Sudoku. So I was like, all right, I have the idea. Now I just got to figure out how to generate these puzzles, right? So I know how to solve them. I know about them. And thankfully, someone else already did this for me. I found this package called Sudoku by Glenn Fowler. When he produced this package, he was working at AT&T Research. And it's just a C program, basically, that you can install and create Sudoku puzzles. It's also a solver, too, which is pretty neat. But what I needed it for was creating. So let me give you a basic usage of it. So this is an example that's in the README. By the way, the README is like 9,000 words long. This thing is incredibly complex, and you can do all sorts of weird things with it. But here, I decided to generate 100 minimally symmetric puzzles limited to pairs and X-wings. Okay, so the dash G, as you can probably imagine, is to generate. And then we have a dash N 100, that's to create 100 of them. The dash M means it's minimal. And a minimal puzzle is basically, if you start removing all the different clues and you remove one last clue, that puzzle is now solvable by multiple different ways. So it's basically removing every clue you can until it's only solvable by one solution. And then SG, S is basically the symmetry that you want to generate. The G kind of rotates, I guess it's a lack of a better word, it rotates the symmetry types as it generates these puzzles. So you can have multiple different symmetry types. And then the dash Q, this is our constraints. And so this is all the different strategies that we'd like to implement this puzzle. We'd like to generate this puzzle. In this case, it's limited to, like I said, pairs and X-wings. And then the dash E, this program even has its kind of own little internal programming language. So in this case, we're making sure that it's a valid puzzle, so it's solvable, and it is minimal. Again. Also, a valid puzzle is one that, in this case, you don't have to guess at all to solve it. It's all logic using these incredibly, complex strategies. But it is solvable completely by logic, so you don't need to guess. So you can see the output here. I stopped it after 4 or 5. But look at that second line. That's the second output. I'll kind of go into more depth. So each of those little numbers, you can see it starts with, I can't see. Starts with a dot. So the dots are blanks. So in that particular square, you start feeling like you look at a Sudoku puzzle on the top left. This is your top left. The top left will be a blank, and then a blank, and then a blank, and then a 5. Okay, so the 5's in that first thing. And then it just kind of wraps around, and that's how it generates the puzzle. After the hashtag, you got a 97,563. That's the rating of the puzzle. The way it outputs its ratings are from 0 to 99,999, and it's an exponential curve. So you can tell that 3 of those puzzles are really hard, and 2 of them are pretty simple. That's just how it output it. The next one are the actual solving strategies you need to use to solve this particular puzzle. In this case, this one requires naked singles, hidden singles, box claims, hidden tuples, a singles knot, which is also known as a by-value/location contradiction chain. And then the next one is the C. That's basically how many clues are given at the beginning. So in this case, there's 26 clues, and it's a minimal puzzle. That's what the M means. And then finally, it tells the symmetry. So in this case, the second one there is a diagonally symmetrical puzzle. All right, so I figured out how to generate the puzzle. So now here's the process I thought I would do. So I would first generate tens of thousands of these things, because you can't really say that you can limit it to ratings, but then it just generates. It just keeps on repeating itself until it finds a rating that you wanted it to limit it to. So I thought, well, I'll just generate a whole bunch of them into a text file. Then I'll write a Ruby script to take all those, parse them out, get the constraints and all the ratings, and put that into a database with a Ruby script. Then with another Ruby script later, I would get the puzzles that I wanted, and then generate a LaTeX file. And then from that, I would use that to generate a PDF that I can then print out and bind. And through the process, I found a Sudoku package, a Sudoku LaTeX package by Paul Abraham, which was very helpful in this. So here's the ugly code I was talking about earlier. We're getting into it now. So this is there's no objects. Well, there's objects all over the place in Ruby, but there's no classes here at all. This is all just like a scripting language, okay? So you can see I'm just opening up a file and then just shoving text into this file as I'm going through. So I'm opening the file. Here's the beginning of the LaTeX. It's basically setting up the page, saying I'm using the Sudoku package. Here's how big I want it. Here's how thick I want the lines of the Sudoku puzzle to be. And then but here's where I'm grabbing the puzzles from the database. I'm limiting it. This is January's, so I'm limiting it to a rating between 10 and 100, and I've got a constraint in there too. So I want to make sure that it doesn't require any strategies that he doesn't know yet, and then of course randomize them. To shove those into a months array, and then from there, this is where the puzzle is generated in LaTeX. So it loops through all those months and all those days and generates a puzzle for each of those. In particular, well, you can't really see it on that one, but I'll guess that. Well, line 93 there, that's the main Sudoku. So that's where the Sudoku package for LaTeX requires them to be, like each column and row would be separated by a pipe. And we'll look at that in a second. And then finally, this is where I set up the solutions page, and this is where it's really writing out all the solutions for those particular puzzles. Okay, so let's look at the LaTeX file that generates. Again, this is kind of setting up the page and the packages. Here's what I was talking about a minute ago, where the Sudoku package actually expects it to be like this. So this is pretty easy to read. I mean, you could solve this puzzle, you print it out on a printer, and then you solve that. But of course, it generates something much prettier. And let's take a look at that. And here, the beauty of LaTeX, and the reason why I wanted to use it is because I knew you could do page references, because I wanted to say the solution of this puzzle is on this next page, not put the solution on the same page, because that, to me, makes no sense. And so then here's, again, where we set up the solutions page, and here's the solution for that particular puzzle. All right, so that's what generates this. So you can see at the top, it's got like a header, and it's got kind of a nice header. It alternates based on whether it's an even or odd page, and the puzzle, and then the solution link there. And one of the cool things about making your own thing is you can correct the wrongs that you see in other puzzle books. So for me, puzzle books that have solutions that are like the puzzle 1 and puzzle 2 solutions are right next to each other in the back. It drives me crazy because I accidentally always see the first answer of the next solution. I'm like, I don't want to see that for tomorrow, please. So I just made it to where every month's first day is next to the second month. So February 1st, then March 1st, and so on and so on. So anyway, so here's a solution page. So we got 6 different solutions on a page. And again, you're not going to see it and ruin the next day's puzzle. So I was able to print it out, bind it like spiral bound. This is actually the second book I made for him. I made it for 2 Christmases. So this is the second one he had for 2011. Again, this is old code. And this is the May 11th puzzle for May 2011. So that's it, really. That brought me joy to figure all this out. It brought my dad joy as a Christmas present, and I really appreciate that. So anyway, I want to let you know that I actually wrote a book, Phoenix in Action. I just got my author copies 4 days ago. Crazy feeling. Thank you. I do have I've got 5 copies to give away, so if you're interested in Elixir or Phoenix, come see me. I'll be happy to give you some. And also, for the whole conference, there's a 40% discount from Manning that they gave me. So CTW Bang Bang 19, any book or ebook on Manning, you can use that to get some discounts. So again, I'm Geoffrey Lessel. I appreciate it. I'm Geo Lessel on Twitter and GitHub, and I should have these slides up at geoffreylessel.com/bangbangcon. Thank you, guys.